Welcome to this explainer. Today, we're diving into our really incredible chapter in history, a time when absolute desperation birthed some unbelievable technological miracles. We're going back to the late 1960s. This was a moment when a profound existential crisis forced an entire population to basically rethink everything they knew about engineering and survival. We're going to explore the astonishing scientific feats they achieved under some of the most extreme, crushing conditions imaginable.
So, how exactly do you build a military-industrial complex in a jungle while entirely cut off from the rest of the world? Well, in 1967, when the secessionist state of Biafra declared independence from Nigeria, they had to figure that out, fast. Imagine waking up to find your borders completely sealed off. No way in, no way out. This sparked an immediate, terrifying crisis for millions of people who suddenly had to innovate their way to survival right in the middle of a literal jungle.
The odds were, frankly, almost impossible. You had federal Nigerian forces reaching peak numbers of around 120,000 troops, and they had heavy international backing and highly sophisticated imported arms. And on the other side, Biafra. They had roughly 30,000 troops trapped behind a total land, air, and sea blockade. But here's the thing. This massive resource disparity served as the ultimate catalyst. When you literally cannot import the tools you need to survive, you are forced to build them yourself, from scratch.
Here's our roadmap for today. We'll start with the blockade itself, move into the birth of a special scientific task force known as RAP, check out their staggering weapons and makeshift refineries, look at civilian resilience, and finally, discuss the lost legacy of these inventions.
Let's kick things off with Section 1, the total blockade.
As the war really escalated in mid-1967, federal forces imposed a total blockade, systematically cutting off Biafra from all global supply chains. Now, this wasn't just a military embargo. We're talking about a near-total deprivation of everyday resources. No medicine, no fuel, no food imports, no spare parts whatsoever. The entire population was forced into extreme adaptive scavenging. Think about it. Local mechanics suddenly realized that a rusted exhaust pipe, an old oil drum, or a broken engine was now the absolute most valuable raw material in their village. Everything had to be repurposed.
Which brings us to Section 2, the birth of RAP.
You know, you can't just rely on random scavenging and expect to hold off a well-equipped modern army. You need a system. So they established the Research and Production Unit, or RAP, and this was a brilliant mobilization of human capital. RAP pulled together physicists, chemists, and engineers, mostly from the University of Biafra, and paired them up right alongside local artisans and welders. Picture that juxtaposition for a second. PhD-level academics working in hidden, makeshift workshops under heavy forest canopies to avoid aerial bombings. Without formal labs, they relied entirely on field testing, just pure trial, error, and on-the-fly reverse engineering to build complex tech.
And the very first thing they tackled was our third section, weapons of survival.
Outgunned and outnumbered, the RAP immediately turned their brilliant minds to military hardware. They had to bridge that massive gap in firepower we talked about earlier. And what's truly staggering here is just how prolific this infant, jungle-based industry was. Operating out of these dispersed workshops with little more than hand tools and scavenged metal, RAP produced over 60% of the conventional weapons used by Biafran forces. 60%. They didn't just patch up old rifles, they invented entirely new classes of weapons from the ground up.
To fight back, they completely weaponized the mundane. By mastering shape-charge principles, RAP scientists turned discarded beer bottles, scrap metal, and scavenged fertilizer into a terrifyingly versatile class of explosives called ogbonigwe, which, by the way, literally translates to mass killer. They built footcutter landmines to stop advancing infantry, command-detonated bucket bombs, and even flying surface-to-air and surface-to-ground rockets to disrupt heavy convoys. They engineered devastatingly effective ordnance using completely unconventional, scavenged junk.
Actually, scratch that. They didn't just stop at explosives. They needed armor, too. Enter the Red Devils. These were armored personnel carriers built by stripping down civilian chassis, literally modifying agricultural tractors, bulldozers, and harvesters. They'd weld on heavy scrap metal plating and mount machine guns right onto them. Imagine how resourceful and, honestly, how genuinely terrifying it would be to see a modified farm tractor rolling into a modern combat zone. They lacked advanced metallurgy, sure, but these massive, improvised machines were effective enough to transport troops safely to the front lines under heavy fire.
Now, heavy vehicles need fuel. So let's look at Section 4, refining under fire.
With the seaports totally blocked, regular fuel imports were non-existent. So what do? You build makeshift refineries.
Using a setup known as the Biafran pot, they basically performed artisanal fractional distillation out in the wild. Think about modern refineries. They require multi-million-dollar infrastructure. These scientists stripped all that away down to the raw chemistry. They poured crude oil into heavy metallic cooking pots, heated them from below using wood fires, and meticulously controlled the temperatures. As the crude boiled, they captured the rising vapors through a network of pipes and condensed them in a cooling tank. Through this totally manual process, they extracted usable gas, petrol, kerosene, and diesel entirely off the grid.
The renowned author Chinua Achebe, who actually served during the war, captured this triumph perfectly. He pointed out how these local engineers shattered the myth, which was heavily pushed by European companies at the time, that oil technology was simply too complex to manage without foreign help. These scientists proved that, stripped to its basic chemical principles, high-level oil refining could absolutely be achieved by an indigenous population right there in the forest.
And to put that into perspective, through sheer trial, error, and relentless determination, these jungle refineries eventually produced an astonishing 20,000 gallons of gasoline per day at their peak. 20,000 gallons. Stripped of all modern industrial infrastructure, they literally fueled an entire war effort by hand. This massive daily output was an absolute lifeline, keeping their logistics and military mobile despite a suffocating naval blockade.
This same level of ingenuity brings us to Section 5, Civilian Resilience.
The blockade had caused a catastrophic collapse of the food and medical supply chains. Just imagine your region's entire food supply vanishing overnight. Families had to completely reinvent their diets to stave off mass starvation and severe protein deficiencies like kwashiorkor. With normal protein sources gone and their cooking oil redirected to fuel the war machines, they created what they called Win the War soup. This was a highly adaptive, watery soup relying on rationed palm oil, hunted rodents, and dried stockfish, which actually had to be smuggled in via incredibly risky nighttime airlifts. It was pure culinary innovation born out of sheer desperation.
The overall civilian and medical resilience was just staggering. Without sterile medical equipment, engineers repurposed ordinary oil drums into surgical hospital autoclaves, using steam pressure to sterilize tools and prevent mass infection. When cholera threatened the camps, they locally cultivated anti-cholera vaccines to stop outbreaks in their tracks. They built radio Biafra transmitters using scavenged batteries to keep information flowing. They continuously patched up the Uli airstrip under the cover of darkness, literally filling bomb craters by hand so relief flights could land. And get this, they excavated the Ojuku bunker, a complex, nearly 27-foot-deep underground command headquarters, in just 90 days using minimal heavy equipment. The whole shebang was engineered for survival.
Ultimately, we have to look at how this ends in Section 6, the Lost Legacy.
By 1970, the war came to an end. The sheer volume of troops and imported materials eventually outpaced what could be manufactured by hand. Tactical innovation just couldn't overcome the overwhelming logistical edge of the federal forces. And despite a post-war policy of reconciliation, what happened next is a real historical tragedy of lost potential. Instead of, nurturing this brilliance and absorbing these reverse engineers into a national R&D program, the RAP facilities were suppressed through neglect. The makeshift refineries were left to rust. The Ogbanigwe explosives were explicitly dismantled. The visionary scientists were dispersed back into academia or informal trading, and the national defense industry went right back to relying on foreign arms imports. A massive opportunity to jumpstart an indigenous industrial revolution was essentially erased.
But the spirit of local alternative engineering refuses to die completely. It actually persists in modern Nigerian research today. For example, there's a fascinating 2016 engineering study that demonstrated how to formulate biohydraulic brake fluids using glycerol from groundnut oil and bitter leaf extracts as a viable alternative to imported mineral fluids. Scientists are still looking inward at indigenous plants and local resources, applying that exact same resourceful mindset as the RAP scientists to solve modern engineering problems and reduce reliance on expensive foreign imports. It's a lasting, viable scientific approach. So what does this all mean? That brings us to our final question for you. Do these incredible historical feats prove a unique, localized ingenuity? Or is it just the universal human drive to invent when your survival's on the line? It's a really fascinating debate. Regardless of where you stand, the scientific achievements produced under the crushing weight of that blockade remain a profound testament to human adaptability. Thanks so much for joining me for this explainer. Keep questioning how the intense pressures of our world continuously shape the technologies we create. Catch you next time.